Hello, welcome back to Cracking the Cryptic and a puzzle called String Theory today. Let's crack the secrets of the universe with string theory. And it's by Chef of Death, which is a very evocative name. We've definitely featured Chef of Death on the channel before because I remember that name. It's great. Anyway, I will go through the rules in a minute. And before that, I do want to tell you about forthcoming attractions, the Yin Yang Sudoku Hunt by Itch.io coming up on the 1st of June. I think you're really going to enjoy it, I have to say. The Yin Yang puzzles are great fun. We'll better try and do one before then, just so that everybody's reminded of some of the basics like perimeter codes, perimeter switches and things. And they're not that basic, but they are once you've done one or two yin-yang puzzles. So do a bit of research first is my tip. Now also on Patreon, don't do any research before watching the connections videos, or, well, maybe have a dictionary open before watching the very hard crossword, which is an extreme challenge every month that I take on. Anyway, Patreon's great, there's loads of content there, but so are our apps, which feature, of course, line Sudoku, and there are a number of entropic lines and many, many renbands in that app. And there are quite a few of the said same lines, even in the Fog of War app, so do check that out. Some brilliant constructors have obviously contributed to that. We've also, of course, got SVEN'S Sudoku Pad and our merch linked under the video, but the first link is to this puzzle. Now, Chef of Death has stated the rules, not quite in the way I would, but possibly in a way that makes them even clearer, and provided little letters in the grid for those of you who might be colorblind or struggling with peach versus purple. So, normal Sudoku rules apply. 1 to 9 will go on every row, every column, and every 3x3 box. Digits on a purple renban line form a set of non-repeating consecutive digits in any order. So this could be the numbers 1 to 6, or 3, 4, 5, 6, 7, 8, but in any order. Along a peach entropic line, no digit can be within 2 cells of a digit of the same entropic class, meaning high 7, 8, 9, middle 4, 5, 6, or low 1, 2, 3. Now, I always get entropic and modular mixed up. The way we normally said that in the past is that along a line, every set of 3 digits has to have 1 high, 1 middle, and 1 low. I think the rules are worded in this way because there's a 2-cell line, and that the only rule about that is they can't be from the same entropic class. But it's the normal entropy rule if you've done puzzles with us on the channel before. If you haven't, do feel free to look up a previous entropic line puzzle to get the idea, or watch this video. You can even, as many people do, watch the video and then have a go at the puzzle, or maybe a few days later, just because then you'll know some of the theoretical techniques. There is an element of teaching in these videos, we hope. Anyway, I'm going to give this puzzle a try now. It's called String Theory. Let's get cracking. So, the thing to know about these entropic lines is that every 3 cells you get the same entropic class. So those 3 will be one type, say maybe low. And the reason I know that is because if those are low, these must be a medium and a high digit, and on their left they'll need a low digit, and on their right they'll need a low digit. So that's kind of how this triple alternation works. So let's give them some colours that are not orange or red, no, that are not red, blue and yellow, which is what I'll go for as high, low and middle. I don't know. Actually, no, let's not do the colours yet. Let's come back to that, because I don't know really how to get going. Okay, one thing I do know about renban lines is if there are at least 5 cells, they must contain a 5. So on this one, there is a 5 somewhere, and therefore neither of these cells can be a 5 because they would see that 5. Okay, so there's something going on this line then. Now, this is a 6-cell line, so it definitely has a 5 on, but it also has a 4 and a 6. Oh, and they're all the middly digits. They're all the yellow digits. Well, this is interesting. Okay, so I've worked out that this digit cannot be 5, but there is a 5 on this line in one of those cells, therefore. This can't be 5 because that would see the 5 on this line. Therefore, the 5 on this line is in one of those cells, and now there can't be a 5 in any of these 3 cells, but there must be a middly digit. And there must be a middly digit over here as well, because this is one of each. So, yes. Yes. Okay, I don't... bother. Okay, I'm putting on the letter tool now. Right. Let's call A middly digit, either 4 or 6. And there must be one in this set of 3 because there's one of each entropic class there. It's not 5 because that would see the 5 that appears on this line. So A is here. I mean, we could call the other side B as well. A and B are 4 and 6 in some order. Now, A, because it's in those cells, can't be in any of these cells. But I think A must be on this line because I think a 6-cell Renban line must have all of 4, 5, 6 on. You can just think about that for a moment. Think of the string of digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you're having 6 consecutive ones, if you had the lowest possible set, it would be 1, 2, 3, 4, 5, 6. If you had the highest possible set, it would be 4, 5, 6, 7, 8, 9. 4, 5, and 6 must all appear on this line. They include A and B. A can't be in any of those cells, and that must be A. B itself, actually, must be in one of those 2. Now, I have to be a little careful with these corner marks. I normally use corner marks to represent where something must be within a box. Now, that has not been the case with 5 pencil marked here or 5 pencil marked here, because I've crossed box borders to illustrate the point. Anyway, I've discovered that this cell is A, and I can colour that yellow for middly. That one is not A. So one of these 2 is middly. Now, these digits, these classes recur every 3 cells. So one of these 2 is, well, either B or... No, it could be A, actually. Okay, is middly because of where A appears there and having to alternate. And then one of those 2 is middly on the same alternation basis. And that one is not going to be A. Oh, I can colour 3 as blue, a given digit. Actually, there must be a given digit in this sort of puzzle, otherwise it would be reversible, i.e. you could, if there wasn't a 3 given, you could finish the puzzle with a correct solution, presumably, and then subtract every digit in it from 10 and have another correct solution, except that the 3 wouldn't work. There's a much more important point. There's a much more important point. You may have been shouting at me for 5 minutes about this. That is a set of middle, low, and high. Why I do them in that order? Low, middle, and high. That is a set of low, middle, and high. Obviously, the 9 Sudoku digits contain 3 of each. So this is a set of low, middle, and high. Now, that gets very important because that means that this 6-cell Renban line has got representatives of low, middle, and high on. And therefore it goes down to at least 3, up to at least 7. This line is either 3, 4, 5, 6, 7, 8, or 2, 3, 4, 5, 6, 7. And we know which one, because which low digit goes here? If the line was 3, 4, 5, 6, 7, 8, the only available low digit on the line is 3, and that can't go here by Sudoku now because of the given digit. So the given digit's a lot more than a disambiguator. It's actually helping us start. This, the low digit on this bit has to be 2. And what's more, there is a 3 on the line. It's not there in a middly cell. It's not here by Sudoku. It's definitely here. Ah, this is brilliant. So the 5 that we marked as being in one of these cells that was going to be B. No, the 5 wasn't necessarily going to be B, but it is now going to be B. The 5 has to be in that cell. Oh, sorry. I'm getting my highlighting wrong. And that is obviously a yellow digit, but also very obviously... Oh no, 5 isn't... Oh, hang on. I've got this wrong. The pencil marking's wrong. Oh, I've literally told you about 2 minutes ago that I have to be careful to not assume that my pencil marking of 5s are limited. Right, 3 still goes there. That logic was fine. This digit is not necessarily 5 because 5 can be in any of those cells. It is, however, necessarily B, which is the digit over here, and has to go into one of these two and is a middly digit. So this is now B, and it's not 5. 5 is in one of those 3. That is B, which is middly, and A and B are not 5. So this is a 4-6 pair. Ah, I was going to say that's made this line impossible, but it hasn't. And this line is now very, very interesting indeed. Oh, this is a brilliant puzzle, Chef of Death. I really like this already. This line, by the way, is 2, 3, 4, 5, 6, 7, because we need a high digit here, and that now has to be a 7. Let's just tidy that bit up first. We don't know which of A and B are 4 and 6. We don't know anything about 1, 8, and 9 in this row, but hang on, we do, because 3 now has to be in one of those cells. So the low digit over here is 1, so we do know a bit about 1 and 3. We don't know about 8 and 9. They're split between those lines. We haven't done anything with 8 and 9. What I'm going to do is get really excited about A. A is 4 or 6, and A sees all the cells on this line and can't appear on it. And what that means is that this is what I would call an extreme line. If it doesn't have 4 on it, the 5 consecutive digits are 5, 6, 7, 8, 9, going up to one extreme end of the string of digits. If it doesn't have 6 on it, and this depends on what A is, then it's 1, 2, 3, 4, 5 at the other extreme end. So this line is extreme. I don't know how to mark that. Let's make it light blue to just remind me. It either contains 1, 2, 3, 4, 5, and that's a 6. And then B is on this line. And the reason I was getting nervous for a second is I thought both of those were ruled off all of these positions. That is ruled out of all of these positions, but it actually must appear on the line. If this is a 6, this line is 1, 2, 3, 4, 5, and that's a 4 and must appear on it. And the same with the vice versa case. So this digit now must be B, I believe, because it's the only place that B can get onto this line, and it must be on it. So now 5 is in one of these. And this is brilliant. These are all... Well, if these are low, this is a set of 1, 2, 3, 4, 5, 6. If these are high, this is a set of 4, 5, 6, 7, 8, 9. Wow, and in that case, this would be 3, that would be 1, this would be 2. These are all the same polarity, the same entropic set. I don't know what that set is. I don't know whether it's high or low. But it goes there as well because of the 3-cell alternation. Oh, this is an intriguing puzzle. I really like this already. That B digit, yes, we know it's over there. We know it's in one of these three, and it can't be there. This digit is the same as that one by alternation. So now we're colouring. I want to colour blue, yellow, and red, but I'm using purple and light blue as proxies for now, until I can figure out which is which. Do I know about this line? I don't think so. Right, what is purple not? I mean, what a mad question. But purple is not yellow, because 4 and 6 are there and 5's down here somewhere. Purple is either high or low, so it's not yellow. So one of these two, which goes in this set of 3, must be yellow. And that's going to be the third yellow, and it's not A or B, it's going to be 5. The third yellow in the box, and now that's not 5, and 5 appears down here somewhere. Maybe I should colour these light blue and yellow, because one of them's a 5, but 2 of them are light blue. 5's in one of these 2 cells. Right, this is the same polarity, the same entropic set as that. It cannot be yellow, because that would be 4 yellows in the box. There's only 3 in each box. So that is not yellow. This is the yellow 5. We've found a 5 in this box. That is now yellow because it's 3 cells away from that. These 2 are the same colour that is not pink, and that is light blue. And now we've got, oh, we know this is yellow, right. We've got 3 yellows and 3 light blues in the box, and these 2 are purple. And in this row, we've now got 3 purples. This is either yellow or light blue and repeats its entropic set here. No, it doesn't. This is a Renban line mark. It is not an entropic line. Don't be doing alternation on Renban lines. That is just an easy way to confuse the brain out of me. I hope you're following my colour marking, because I just about am. And if I'm struggling with it, it might be a bit difficult to understand what I'm getting at, but it's very interesting. How are we ever going to know actual numbers? There's not really much. Now, this Renban doesn't have a 3 on it, because that 3 sees all the cells. So this Renban is, it therefore can't have 1 or 2 on it, because if it had those, it would necessarily need a 3. So there's no low digits on this Renban. One of these 3 is low. That one is low, and one of those 3 is low. So this one is not low either. Ah, yes, this is good. This is a good deduction. Because in this box, we've had a low digit there and a low digit there. We can't have 2 low digits here. We can only have a maximum of 1. These can't be low because of what we've just discovered about this Renban. So in this row, we've got a maximum 1 low there. We've got 1 low there. We've got a minimum 1 low here. And the low number here is a 1. Because we've used 2 and 3 in the box. So there is a 1 in one of those 2 cells. But if you put it here, there'd be no low digit for that stretch of 3. And that wouldn't work. So this is the 1, this is the low digit. And it also alternates along the lines in these positions. So they're not yellow, they're now blue. And the yellow digit on the line has to be here. And it is A, isn't it? Yes, it is A. That is A. It's a middly digit. 4 or a 6. Oh, it's not the same digit that necessarily repeats, but yellow does repeat. That is not a 1. And now I think we know that this colour, this purple colour, has to be high because of this trio. And now the light blue colour has to be low, and light blue appropriately turns darker blue. And there we go. We've established the entropy sets. This is a 1 because it's low, and this is not low. This one is 4 or 6, obviously, A. In this box, oh, this is a 2. Goodness me. Okay, we are getting digits now. That's a 1-3 pair. This is 4 or 6, obviously being B. The 5 in box 1 is in one of those positions. Ah, goodness. Okay, what do we know about this still? We know that it's selected from 4, 5, 6, 7, 8, 9. It must have 6 and 7 in it. The 7 in it cannot be there because of the 2, 5, 7 triple. So the 7's in one of those positions. The 6 is in one of these. I'm a little reluctant to mark across boxes again since I tripped myself up a moment before. This digit is 8 or 9, as is this, because they both see the 7 that's in these. Gosh. Right, what else is here? No. What's here? Because in this box, we've still got one middly and one high digit to place. If that was middly, it couldn't be 6. Because 6 is on this line, and all of those cells see that cell. All of these cells see all of these. This can't be a sort of internal to the line. It can't be 6. I want to say it can't be 8, but I'm not 100% sure about that. If this was 4, 5, 6, 7... Yeah, I'm not sure about that. I'm not sure if I can do much else here at the moment. I think that cell might be interesting, but I can't quite work it out. I'm going to try and move on to this square down here. Am I? I don't know. Let's think about it at least. Now, I tell you what, I'm going to pencil mark 4 or 6 there. 4, 6, 8 or 9 in those cells, because I'm never scared to over pencil mark things. Right, down here we're selecting from 4, 6, 7, 8 and 9 because we've used 1, 3, 2 and 5. Now this group of 4 cells is a Renban. We can't have both 4 and 6 here because that would break this cell. So one of these is high. One of these is 7, 8 or 9. That tells me that the least little information that I was trying to find out, which was can we say there are no blue cells on this square? And we can now, because one of these is 7, 8 or 9. For one of them to be 4, this would have to be 4, 7, and this would have to be 5, 6. That is just possible, but it's very annoying. I suppose these could both be high. But, well, these, I mean, you know, I do at least know that these can't have a low digit on. Because there is a high digit here, and it might be a 7. And even if it's a 7, you couldn't get below 4. So these 4 are all from, and that one, are all from 4, 5, 6, 7, 8, 9. So it's getting quite hard to squeeze the low digits into column 4, 1, 2, and 3. Oh, hang on. This Renban does not have a 3 on because of that and this pair. Oh my goodness. Well, this is interesting. So it doesn't have a 3 on, so it can't have a 1 or a 2 on. It's all made up of middly and high digits. So is this box here. Let's just start colouring for that light. I've only got 3 cells left in the central box where I can put low digits. And this one sees a 1-3 pair, so that's 2, that's 3, that's 1. That's weird. This is now not 2, this is again, yeah, look at that. All of these are yellow or orange. There's only one place to put 3 in this column, and I found it there. There's a 1 in one of these Renbans, and that makes whichever Renban it is be a 1, 2, 3, 4 Renban. And its 3 must be in one of those cells. And the other Renban of these pair does not have a 3 in, and can be coloured like these ones. Now, could those all be high? No. We've got 1 high and 2 middly here. So this is 1 middly and 2 high. Does that tell me anything about these two? Not really, I don't think. Oh, this is a 1. It's low and it sees 2 and 3. Hadn't noticed that. The 1 in this box is now in one of those 2 cells. This is not low and this is not low. I mean, I don't love doing these part coloured cells, but it's quite interesting. This has become a 5-2 pair accordingly, actually. So you do find out things, even with slightly confusing colouring going on. That's 4 or 6. No idea whether it's A or B, but it sees a 5. This Renban has got a 5 on it, of course. And it has another, well, at least one other middly digit, because it's 5 cells long. It's got to have. If it has B on it, B has to go there. It could have 3 middly digits on, but I think it's really hard for it. I don't know. I mean, maybe it's not. That's a 2-5 pair. Right, where's 2 in this row? It's not on that Renban, so it's there. This is now 5. These, do we know how many are middly and how many are high? Ah, we know that none of these cells are 5. So now we know that 5 in this row is here. And now we know that this Renban has 5, 6, 7 on it and doesn't have 9 on it. It's either 4, 5, 6, 7 or 5, 6, 7, 8. The 6s, the positions for 6 all see that cell, so that's not a 6. Five, 7, and I don't know, not 9. So 9 in the row is in one of those 2 cells. Right, we've got the 3 yellows in this box, so that one is high. I thought that was going to do something. It absolutely didn't. 1 of each there. Now, if that was a 4, that's 6. These are 5, 7, 8, definitely. And that would be 6. Now, I don't know. I don't quite know what's going on. Down here, we've got a 2 in one of these cells. and 5, and either 1 or 3. Oh, we know that this is 4. For goodness sake, it's on a line with 1, 2, 3, 5. 6 there. We know what A and B are. B is a 4. There we go. This digit, I still don't know though whether that's A or B. Right, 4, if it's on the line, 4 is now, I'm going to say it's in one of those two cells. I'm not absolutely sure that's right. Is it right? No, I don't know. I'm not risking saying that. I don't quite get my own reasoning. It's a bit sad, isn't it, when you can't work out your own reasoning. Right, 4 is not on this line. These are definitely from 6, 7, 8, 9, the quite high digits. In fact, so are these. And that can't be 6. 6 is in one of these 3 cells. What are these? One of each colour, including a 4, a 1 or a 3, whatever that is, and whatever that is out of orange. Anyway, let's go back to this line, which was what I was trying to focus on and failing. I don't think that 4 can be on this line, because that would have to be a 4-5 pair. Well, maybe it does work. That could be 6, 7, and then an 8, 9 pair there. Okay, maybe that is an impossible assumption. Well, impossible in the sense of I daren't make it. Oh, look, those are 2 blues. That's 2 and 3. Honestly, I should have kept up this yellow-orange part colouring. There it is all again. There's quite a lot around. Oh, let's go back down to these lines. Now, we worked out one of them has a 1 on. So if that was 1, 2, 3, 4, that would be 3. This would be 1, 2, 4. That would be 5. If this was 1, 2, 3, 4, that seems more feasible. The 3 would be in one of these cells, obviously. Yeah, I can't quite get my handle on that. Now, if I worked out, I didn't work out that 9 wasn't on this, did I? In fact, I haven't really worked out much about it. I suppose we know it's all high and middly digits, so it's got to have 5, 6, 7, 8 on this line. And either 4 or 9. If it's got 4, we know it's there. This is 4 or 5 because it's not 6. I hadn't done that before. The 6 in this box is in one of those cells. The 6 in this box is in one of those 2. None of these can be 4 or 6. Oh, I don't know. The entropic alternation, I mean, we're basically done with that. There's nothing else to learn about the entropic alternation. 2, 5, 7. These are from 3, 4, 8, 9. These are from 5, 7. Well, have I ruled out 4 off this line? Well, I have off those cells. I've ruled 9 off the line because 5's on it. So these are from 5, 6, 7, 8. So 1 and 2 are in this row. I mean, that's so unexciting. It's ridiculous, but there we go. Right. Does there have to be... Okay, let's say this was the 1, 2, 3, 4 line. This is either a 1, 2 or a 1, 4 pair in that case. Okay, I might be on the verge of saying that that's a 2. In this column, where is 2? If it was here, there'd be a 1 on this line, and both of these lines would have to have a 3 on. So 2 is not there. If this was a 1-2 pair, that would be a 3-4 pair. Oh, that's probably doable. Oh, bother. I think we're pretty close here. It's a very good puzzle. It's really interesting. Maybe I just haven't thought about this. This has to have, it's a bit like this line. It's a 4-cell string from 4, 5, 6, 7, 8, 9. It has to have 6 and 7 on it somewhere. But then I just don't know after that. I don't know what flavour this cell is. I mean, a lot of this is done. Oh, bother. If that was 8, this would have to be a 5, 6, 7 stretch of line. That would become 9. Actually, maybe I could rule 9 out of here. That would be really useful. If that was 9, this would be 8. Doesn't really do anything else, does it? Oh, I think I'm being a bit dead. It's got to be the Ren bands that are going to help. Got to be. Gotta be. Right, 3 is in one of these 3 cells because it must be on one of these lines, whichever one has the 1 on. If that was a 1, this would be a 1, 2, 3, 4 line. That would see both of these cells. I don't know what that does. This can't be a 3. Let's just do the basics. Five is in one of those cells, and there's a yellow one in one of these. 4 is in one of these. We know that. Okay, let's focus on this line. I'm really missing the trick here. If that's a 4, that's 5, 6, 7, 8, and that's 9. And then 9 would have to be here. And then that would have to be 9 in row 3. Okay, that's getting interesting. I'd tell you one reason it's getting interesting is putting 9 somewhere in box 9 is getting a little bit tricky then. I don't know. Sorry, I'm really missing a trick at this point. Oh, 4 in this box. Ah, there we go. That's really quite important. 4 in this box must be in one of those 2 cells because this one is not middly. So that's a 5. And that's not a 5 now. Oh, maybe it wasn't all that important. That's annoying. I thought it was. There is a 4 or a 6 in one of those cells. There must be a 5 on this line, so it must be in one of those 2. There is a 4 or a 6, but only one of them here. The other 2 are from 7, 8, 9, obviously. can't rule out that they're 8, 9. But that would put a 7 in one of these two. I feel like I'm just missing the point a bit here. There is 4 is in one of these two cells along with 6. Ah, there is the point. There is the point. That is a 4-6 pair. That is yellow. These two are both orange. 5 is in one of those. Or maybe still this isn't completing anything, but it just feels bigger now. Now, how could this be a 4? That would have to be a 5-6 pair. And that would be 7, 8, and this would be 9. And I mean, does that keep working? Bobbins, it does. In this row, I mean, I could have marked up all of these cells as containing 7, 8, or 9 anyway, just because of their orangeness. Oh, I was going to do red as high. I remember that once. That all went by the by, didn't it? Okay. I was about to announce that there was a high digit down here, and that's one of these is middly or high. I mean, they're obviously not all low because 3's not here. Maybe 2 of them, because if that's a 2, then that could be a 1, and these could both be higher. Okay, that's not getting it done still. There is a 5 in those two cells. Might be able to say that there must be a 5 on one of these renbands. Can these both be extreme renbands? I don't know. Should I know? I don't know. I have a feeling I might be able to theoretically know, but I don't. And I still don't know which of those is 4 or 6. The renban is the only one that can tell me. If that was middly, these would have a low and a high and something else. Oh, I can't see how to resolve this. It's absolutely fascinating, but I cannot quite get through it. I mean, I'm also quite interested in the fact that you cannot put 1 on any of these cells. Or, no, I was going to say or 2. That's not necessarily true. But you can't put 1 on any of them. So 1, I could either place in those cells, or annoyingly it could be here. And that just gives a lot of freedom here. There is a 6 here. If 6 is on one of those cells, it can't appear on the renban again, and that would be a 4. If it's here, then this is 5 and a high digit, and that would be 6. Oh, that's the opposite. That's so annoying. If 6 is here, 6 is on the renban there. If 6 is here, that's a 4. And then this has to be 7, 8, and that has to be 9. So this is either 9 or 6. That's weird. If it's 6, yeah, this is either 6 or 9. If it's 6, it's 6. Otherwise, 6 is there. And that makes that a 4 on the renban, and that makes that a 9. Right. What did that do? I mean, it's not going to have done anything. But this digit is going to have to appear somewhere here, along with this one. I mean, oh. It's really on the verge of doing something interesting, that. 3, 5, 6, 2. These are from 4, 7, 8, 9. I mean, there's no point pencil marking that, I don't think. But still, I seem to have done it. 4, 6, 8 there. 4 or 6 there. I wish this line alternated. It just doesn't. It's not meant to. This line isn't meant to alternate either. No, I said earlier, I've done all the alternations. There's nothing else to learn from those. I am so interested in whether there's a 2 in one of these cells or one of these. And I can't figure it out. 3. So if the 1 is here, this is 1, 2, 3, 4. And there would have to be a 3 in one of those cells. Thrilling, isn't it? Oh, maybe I should just be labeling the high digits. I hadn't thought about doing that, actually, not at all. That is the same as that. It's an interesting concept. Those two, obviously the third of the high digits appears here. That's the same as this one. I don't know. I don't think it gets us very far. I don't think I can label the high digits with any degree of success. But I'm not sure about that. If this was 9, this is a 7-8 pair, and that's 9. We've got 9s in these positions. The 9 in row 3, that's what we learn about then, is here. Now this doesn't have a 9 on. And therefore, it must have a 5 on. And that 5 would be in one of these cells and would make this a 7. Now 9 would be here. So we'd have 9s in these positions, one of those two. Ooh, 9 would end up in one of these. And these Wren bands would have to be 9, 8, 7, 6 and 1, 2, 3, 4. Again, no 5. I mean, there's a lot of implications, and they're quite interesting. But do they butter any parsnips? Probably not. It does make me think that the whole secret of the puzzle is in this square now. If this is the low one, sorry, if 1 is on this, then this is 1, 2, 3, 4 in some order. Now, what does that do? It must do something quite big. These are 1, 2, or 1, 4. This wouldn't be low anymore. I don't know. I was very appealed to by this being a 9. It got very interesting in a hurry. If 5 is on this, oh no, well, then 9 isn't. But where I got to 5 being on it was from 9 being in those two cells, which I think is interesting. Let's carry on. 9 there makes that 9, and that makes that 9 in the row. In column 1, in row 1, 9's now in box 3, so that's also a 9 in this situation. And now 9 has to be in one of these cells. I don't know what it means. If Can I rule 8 out of there? Can I rule 8 out of here? This is... Oh, this isn't 4. Look, I've got a 4 there. This is high. This has been available for half an hour or something. That's an 8-9 pair. I can rule 8 out of here. Oh my goodness. Putting that 4 in, I never tidied up that pencil mark. I mean, I would have done if I'd seen it, honest. Well, hang on. This is an 8-9 pair. 5 and 7 we know are over there. I could tidy up that pencil mark as well. There's a 7. Now I don't need to be labelling these high digits because they're actually occurring. One of these is a 7. Come on. 5 and 7 there. I feel like that can't be... No, this is now 5, 6, 7 as a triple. And that can't be 6. That's 4. Oh, goodness. It's just been sitting there available. That's a 6 now. This is where we need the action. We don't have a 6 there. We have a 6 here. This is 5... Well, 5, 7, 8, 9 are a quad here, obviously. There's a 6 down here. This is not 6. So these don't have a 6. There must be a 6 on this line, so it's now on this side. That's not a 6. That's a high digit. Now, in this column, 4 is down here. 4 is on this line. So the line also has a 5 on, which is also on this side. That is a 4-5 pair. This side is 6 and 7. My goodness, it's just been sitting there available. That 4-5 pair makes this a 7 at the top. Sorry, you've probably got very hoarse shouting at the screen. And I'm entirely to blame. And I feel the weight of that responsibility. That's not a 7. One of these is a 7, so there's no 7 there. Down here, this is interesting. These are from 1, 7, 8, 9. Well, we can't put 1 with 7, 8 or 9 down there, so this is the 1. That line needs a 3 on it. We know where it goes. Those are low digits. These are a 2 and a 4. That is now 5 and yellow. These are blue and they are, I don't know, they're blue. They include a 2, that's what I do know. These don't have a 1 on, obviously. They are definitely high. There must be a 6 on this line, and that's not a 6 now. That's not a 3 by Sudoku. 3, 1, 2, 4, 5. That's not a 4. Or a 6. It's high. It's the third high in the column. Down here we have a 4 and a low digit. 5, 3, 1, 2, 4. That is the only place for 6 in the row. This is high. This has at least got 8 and 7 on it. These two digits are either 6 and a high 1 or 6 and 5. I don't know the answer. That's a 2 by Sudoku. That's a 3. This is now 4 and that's 2, and we can colour those properly. 2, 2, that's a 2. Can I do 1 up here as well? Yes, I can. There it is. This digit is 8 or 9 and definitely high. 1s, 2s and 3s. I could have got a 1 in one of those cells. 2, 4, 3. Now, in this column, we need a 3. I think it's got to be at the top. Yes, tidying up the pencil marks a bit, because it turns out that's always valuable. Who knew You all did. Right. Now, there's still this tiny little entropic thingy to do, which is really quite weird. It doesn't have a low digit on. So this is one of each middle and high. I don't know how to use that yet. Do I? No, I don't. There's a 2 in these cells. 1, 2, 3. I mean, this must all be just done somehow. One of those is a 5. That's not a 6. That's 5 or 7. Let's look at this final column. 4 in it. Oh no, it could be in one of those 2 positions. 5, 7, 8, 9. 7 must be there. Okay, that's not a 7 because 7 in box 4 is in one of those. So that's now an 8, 9 pair. This is a 7. That takes 7 out of those cells and makes this one a 5. I know its colour. I know, no I don't know the colour of those 2, but I know they don't include 5. This final column again, these don't include 4. They're from 1, 8 and 9. Now, there must be a high digit on this line because it's high and middly. There's a high digit there and there's definitely a high digit here. So this is middly. 5 or 6. I feel like that must be an important deduction, but I don't really know why. Oh, 4 is placed at the top. There we go. That's 4. Now, this can't be middly anymore and is not 4. This is definitely 4 and is yellow. In this column, hasn't really done anything. There's a 5, and this is the only place for 7 in the box. That's going to give me 7 in box 4. I'm trying to be fairly cautious here because I don't want to mess up. That 7 gives me 6 and 7 here. That was something I wanted. 6 there places 6 down here. That is middly. This is therefore 5. These are a 7, 8 pair. That is going to really help. This is high and is 8 or 9. This is not 5 anymore. I said not 5. And then I mistyped. So that's high. This is 5. That's high. Okay, I've got loads of 8, 9s to unwind. They're all going to happen at some point. That's a 7, 8 pair. Here it comes. 9 there, 8. Now, watch these 8, 9s unwind. It's going to be fun, I feel. 8 there, 9, 8, 9, 8, 9, 8, 9, 8. Perfect. This has become 7. We're really very much finished off now. 9 and 8 there. Still haven't done these 1, 2, 3s, but they'll come in a moment. 4, 5. This is a 2, 9 pair which can be filled in and coloured because why not? That makes this a 1, and that is going to sort out these low digits, which I was a little bit nervous about. Puts a 1 in the corner in blue. That is an 8 now, because it can't be 9, very obviously. 7 and 8 there. 7 and 6 here. Better finish off the colouring for completionists. Down here, 7 is orange, sorry. That's a 4. That's a 5. We've got a 4, which is yellow. We've got another blue digit, which is a 3 in the corner to finish off. And string theory is complete. I don't think it was as difficult as I found it. Literally just not, what was it? Some sort of pencil mark with a 7 around here that I had just missed for ages. No, it was that 4, wasn't it? Big coming out of that cell. Oh, bother. Anyway, it's a brilliant puzzle. I hope I haven't botched it up, and I hope Chef of Death enjoyed that. They probably enjoyed watching me struggle. But it was a clever puzzle. Great fun. Thank you for watching us. Hope to see you soon. Bye for now.